In the last video, I seemed to be stuck between a rock and a hard place. I had a method that needed a collection of any type of student, but I found that I couldn't pass an array list of LPA student to that method when I specified student as the type argument for the list in the method parameter. When you declare a variable or method parameter with list of type student, only list subtypes with student elements can be assigned to this variable or method argument. You can't assign a list of student subtypes to this. I finished off by using the raw version of list as the method parameter, but told you this isn't recommended. So where does that leave us? I could write a second method that takes as its parameter a list of LPA student. You probably know that's not a good solution either because of the duplication of code. That would also mean our code isn't extensible because any time a new subclass of student is added, I would probably need to add a new method. Doing these things defeats the very purpose of using generics. Fortunately, we do have several other alternatives. One of them is to make the method a generic method. You can create a generic method on any class, not just on a generic class. I'm going to set up a type parameter for this method, and that goes in angle brackets just before the return type, which is void in this case. I can use T where I would otherwise have a type, so I can include angle brackets T after list in the method parameter. That fixed the problem, and I can run the code with the same results and no warnings. Here, instead of saying this method will take only a list of student, I'm saying it will take a list of any kind of type. Later, I'll show you other ways to do this, but I do want to pause here to talk about a generic method first. For a method, type parameters are placed after any modifiers and before the method's return type. The type parameter can be referenced in method parameters as the method return type and in the method code block, much as we have seen how a class's type parameter be used. A generic method can be used for collections with type arguments, as we just saw, to allow for variability of the elements in the collection without using a raw version of the collection. A generic method can be used for static methods on a generic class because static methods can't use class type parameters. I will look at this more shortly. A generic method can be used on a non-generic class to enforce type rules on a specific method. The generic method type parameter is separate from a generic class type parameter. In fact, if you've used T for both, the T declared on the method means a different type than the T for the class. I'll also be looking at this shortly. Like a generic class's type parameter, we can use upper bounds for the type, which both restricts the types we can pass, but allows us to use that type's methods. Going back to the main class and the print list method, I'll first add the upper bound, which will be student. This means I can pass a list of students or LPA students to this method. Now I can only use this method for a list of students or a subtype of students. Because I've done that, I'm able to use student methods within this method block. I have one method unique to the student class, and that was the student getYearStarted method. I'll print that and student there. Let's run this and review the output. You can see I'm outputting the year at the start, followed by the string representation for each student. Although this solution allowed me to demonstrate generic methods, it still may not be the preferred solution. I'm going to copy that method and paste it directly below, but not because I want two methods that do the same thing in this code. I want to leave this generic method in this code so that if you're reviewing it later, you can still see it and explore it. I'll rename the new method to print more lists. First, I'll change this method back to the way we originally had the previous method, passing a list of student and not using type parameters. In other words, I don't want this to be a generic method. Next, I'll change the type argument being used in the method parameter. So in the angle bracket, where I have student defined, I'm going to add question mark extends and leave student there. So what is this? This syntax is what Java calls a wildcard in the type argument. A wildcard is represented by the question mark. Let me pause here to discuss some relevant terminology so that we're all on the same page. A type parameter is a generic class or generic method's declaration of the type. In both of these examples, T is said to be the type parameter. You can bind a type parameter with the use of the extends keyword to specify an upper bound. A type argument declares the type to be used and is specified in a type reference, such as a local variable reference, method parameter declaration, or field declaration. In this example, baseball player is the type argument for the team class. A wildcard can only be used in a type argument, not in the type parameter declaration. A wildcard is represented by the question mark character. A wildcard means the type is unknown. For this reason, a wildcard limits what you can do when you specify a type this way. I will talk about this shortly. A wildcard can't be used in an instantiation of a generic class. The code shown here is invalid. A wildcard can be unbounded, or alternately specify either an upper bound or lower bound. You can't specify both an upper bound and a lower bound in the same declaration. Let's get back to our code to explore some of these concepts, then I'll summarise when you'd want to use these different variations. Back in the main method, I want to invoke this new method in the two instances where I was invoking the previous method. I'll copy and paste each of those, then comment out the first invocation. Notice my code now compiles and I can run it. I get the same formatted output just like I did when I called the generic method printlist. Inside this method, I'm still able to call the student.getYearStarted method. This is because I'm specifying an upper bound using the extendStudent expression. This means the code in this method knows that anything coming in on this list will be a student or its subtype. Let me remove that upper bound next. As you can see, by doing that, I've reintroduced a compiler error because I'm trying to use a method that's on student. This unbounded wildcard is just the question mark alone. It doesn't restrict what types my list can contain, but it does limit the functionality I have in the method. What happens if I change this to a lower bound? I'll put superstudent there now. Even though I'm specifying student in my wildcard expression, I still get the same error. Why is that? Well, a lower bound means it can be a student or any parent of student, which is an object in this case. An object won't have the method getYearStarted on it. So again, using a lower bound also means you either have to cast or limit what operations you're performing on the type in your method. Let me remove that call to getYearStarted in this method, and I'll just print out the student alone. That fixes our method, but notice the compiler error in the main method now. I've got an error on the call where I'm passing the list of LPA students. That's because I've said I'll only take students and not subtypes of students by using this kind of wildcard with a lower bound. Going back to the print more lists, I'll change super back to extends so that I have an upper bounded wildcard. Is this solution better than the last one? Meaning, is it better than using a generic method? Well, like anything, the answer for that is, it depends. This is the best solution to the problem I've described and for the method I'm showing here. In this method, I'm using elements in the collection and I can access functionality specific to student elements. But I'm not trying to add or set an element in my list in this code. Let me try to do that. Before this for loop, I'll try to assign the first element to the last. Student last equals students.getPassingStudents.size -1 students.set, and I want to set the element at index 0 to the element that was the last student, which is in the last variable. Now I've got another problem. The error messages required type capture of question mark extends student, and the provided type is student. What does that mean? It really means that this method with wildcards has no way of knowing the type of the list elements that is getting passed to it. They're unknown. It could be one of many types subclassed from student. In other words, the compiler doesn't have enough information to enforce the type checking rules. It knows there are rules because we're using type arguments, but it can't safely say if this list is a list of students, a list of LPA students, or a mix, so it won't let you add an element. Wildcard capture is the ability of the compiler to infer the correct type parameter, and here it can't do it. I'll revert that last bit of code, removing those two statements, and this compiles again. Now that we know about type arguments and wildcard syntax, let's talk about how generics work at runtime. Generics exist to enforce tighter type checks at compile time. The compiler transforms a generic class into a typed class, meaning the bytecode or class file contains no type parameters. Everywhere a type parameter is used in a class, it gets replaced with either the type object, if no upper bound was specified, or the upper bound type itself. This transformation process is called type erasure because the T parameter, or S, U, V, or whatever, is erased or replaced with a true type. Why is this important? For the most part, this isn't really something you have to be too worried about. But understanding how type erasure works for overloaded methods is important. In the main class, I'll create a static method that takes a list of string, public static void test list with that list of string. For var element :list, I'll print out that it's a string and the element using to uppercase, and I'll copy that method and paste it. In the copied method, I want to change the method parameter to be a list of integer, and I'll print out integer in place of string and call element.floatValue instead of calling element.toUppercase. I'm using the floatValue method just to use a method specific to the integer class. This looks like a valid way to overload the method. The first method takes a list of string, and I've overloaded that to take a list of integer. But you see I've got an error on that first test list method. The message I get is that the two methods clash because they have the same type erasure. A list has no upper bound declared for it, so it always resolves in bytecode to a list of object. In both of these cases, the method parameters after type erasure would be a list of objects. This means these methods won't overload each other in the bytecode. They'd have exactly the same signature, the same name, and parameter type. So how would you code something like this? I'll comment out both of those two methods and start with a new method. Public static void test list, and again I'll pass a list, but with an unbounded wildcard called list. And now I can take advantage of the instance of operator with pattern matching to handle strings and integers differently. Check if element is a string. If it is, print the uppercase string. Otherwise, check if it's an integer. If it is, print the float value of the integer. I'll make a call to that method for two very different types of lists in the main method. I'll call testList with an array list of strings, and then with an array list of integers. I'll run that. And whoops, we have an error. I think I may have missed a closing curly brace. Let's take a look. Yes, that was the problem. I'll add that and run the code again. I get the output from this code segment, first my three names in uppercase, then my three integers printed out as doubles. In this video, I introduced you to generic methods, wildcards, and type erasure. In the next video, I want to cover the final few topics, which are static methods in generic types, more on type erasure and multiple upper bounds.